Okay, in this example, notice that there's a couple of things that are different. Well, one major thing, and that's going to be that we are asked not to find all the solutions on 0 to 2 pi, but we're asked to find all the solutions, period, to this equation. So all the solutions to the equation. And that means that we want to identify every single possible thing that could possibly be a solution, not just on one rotation of the unit circle, but everything. And that's where these adders that you see here come in. And I'll talk more about those in a few minutes, okay? All right, so let's take a look at what we have here as our equation 4 sine squared of theta equals 5 plus 4 cosine of theta. Okay, so a couple of things that I see right away are that I have more than one trig function happening, right? I've got a sine function here and I've got a cosine function there. And that means I need to utilize some kind of technique to either separate those two things or replace one with the other. Okay, so first of all, let's put them all on one side of the equation and let's look at what we have. Okay, so we would have 4 sine squared of theta minus 4 cosine of theta minus 5 is equal to 0. Okay, so it almost looks like a quadratic, except that I have two different trig functions going on there. Now, if I could factor this expression so that it separated the two, that would be an option, but that does not actually work here. So I'm going to keep in mind what I remember from our experience with Pythagorean identities. And remember that sine squared of theta plus cosine squared of theta is equal to 1. That means that if I move this cosine squared of theta to the other side, I would have sine squared of theta is equal to 1 minus cosine squared of theta. And so that means that since these two things are equal, I can replace sine squared of theta with 1 minus cosine squared of theta. So let's go ahead and do that and see what we've got. 1 minus cosine squared of theta minus 4 cosine of theta. Okay, so I've replaced this. I'm going to go ahead and just distribute and combine my like terms, okay? So I've got 4 minus 4 cosine squared of theta minus 4 cosine of theta minus 5 is equal to 0. Okay. This looks better because notice now that I've got all one trig function. I just want to clean this up a little bit and then I will use my quadratic tools and solve this equation. Okay, so there's a couple different ways to think about this. One is to combine the 4 and the negative 5 and then multiply everything through by a negative 1. I prefer to think about it as just shifting everything to the right side of the equation because that's going to make our first term should be positive if we're going to try to factor. Okay, so that's my thought process there. So, well, let's just move this 4 with this and put this 4 with this negative 5 And we'd have negative 4 cosine squared of theta minus 4 cosine of theta minus 1 is equal to 0, right? And then if I multiply this entire equation, both the left side and the right side, by negative 1, I do that to make that first term positive. I will end up with 4 cosine squared of theta plus 4 cosine of theta plus 1 is equal to 0. And then I can think about this as let u equal cosine of theta, and then I'd have 4 u squared plus 4u plus 1 is equal to 0, which would factor to be 2u plus 1 times 2u plus 1. All right. Set that equal to 0 and say that u is equal to negative 1/2. And then plug that back in, so cosine of theta is equal to negative 1/2. And then we would think about, where does that happen? That's going to happen on our unit circle where the x coordinates are negative 1/2, because we're talking about cosine. And we would end up with theta is equal to, second quadrant is going to be 2 pi over 3. And third quadrant is going to be 4 pi over 3. Now let's go back to this idea of all solutions, because what we need to do here is we need to add this adder, plus 2k pi on both of these. All right, and where k is an element of the integers. Okay, so this much is going to be given to you as kind of a building block in your answer. You just need to know when to use it. So let's talk about that. When it says find all solutions, we're going to need that adder, because that adder is really telling us that while 2 pi over 3, let me highlight this for a second, while 2 pi over 3 is a solution, if I went around the circle one full rotation, I would have another solution. And if I went around again, I would have another solution. And each of those rotations is a true solution of this equation. So this is kind of shorthand for I can add as many rotations of the unit circle as I want, and I will still get an answer that satisfies the equation. Okay, so that's why we do that. Now, what are the adders? For all the functions except for tangent and cotangent, the adder is going to be plus 2k pi. All right, like here. Plus 2k pi, where k is an element of the integers. Now, for your tangent and cotangent function, it's going to be k pi. All right, because the period length of tangent is shorter. It's just pi units instead of 2 pi units. All right, so I hope this helps, and I will see you next time.